Okay, in the last video we did quick split on these parts and we developed the shutoffs. Now we're ready to add a mold base and some inserts. So we're going to go to mold design and choose new mold base. Oops. I'm going to set the directory here, what catalog I want to use. Alright, we're going to do PCS. And because we're going to use inserts, we'll use the 9-plate configuration. We can set up margins in here if we want. The software to suggest a mold size based on the amount of steel. I happen to know that 13 by 18 works good in this one. We can go to the top view to get a feel for that size. And we're going to go to the next page. And we're going to set the thickness of the plates. Okay, so we're going to use a 2 3/8 A plate, 2 3/8 B plate. We can increase the ejector stroke if we want to, and go ahead and take that. We're going to take all the components, and the system is now building the mold base, putting all the appropriate components into the appropriate sub-assembly, which is a very, very nice feature. Okay, so now I can easily turn off the A side, and I'm going to temporarily hide the B plate. We're going to activate the movable side, and we're going to choose add duplicate. And then we're going to go into my catalog and go to the insert folder. And I've got some inserts. I got a core insert with sharp edges, which would assume that we're wire burning the pocket out, or a core insert with radiuses, assuming we're going to machine the pocket out. We'll take this one. We're going to place it on the face of the support plate on center. And we're going to change the leading dimensions. So I want to have 4 inches in the height, 9 inches in the length. Actually, no, I think I want 8.5 there. And well, I don't remember. We're going to have to go to the top view and take a look at it. Okay. Yeah, it's actually not too bad. So we'll go ahead and accept that. And we're placing it with cut. There's a cut body in that insert folder. And if we show the B plate, we should see that the corner is actually cleared with the cut object. Okay, so now we're ready to cut the core insert with the core faces and the core parting faces. So if we do that over here with cut active, we pick the target part. It's asking us to pick the split directions, being one of these guys and one of those guys. And because we assign parting attributes, it knows what parting faces are associated with those quick split groups. And so we have nothing more to do than hit the check mark. And this cut operation takes a few seconds because it's essentially doing a lot of unstitch and restitch operations because we never really unstitched the model. The model is still one solid object in reality, but the software treats it a different way during the cut operations. The other nice thing about this operation is that it retains all of the colors properly. A lot of systems that just do a boolean cut, the result is one color where you can't really differentiate between what's shut off and what's part. Okay, so now if we hide our parting assembly, this is the actual core, and as you can see, all the parting faces have a unique color from the actual part area. Okay, so let's see, what do we want to do next? Probably adding some ejector pins would be a good thing to do next. So let's activate the ejection side, and we're going to choose add ejector. And I've got a key pin catalog, and let's take the diameter of 188. You'll notice the length is kind of grayed out. That's for a specific reason. Basically, wherever we position the pin, it's going to pull the right length of pin from the catalog based on the catalog lengths. Probably it would be a good idea here to do symmetry. Oops, that's not it. Okay, and I can do one axis or two axis by a point. We'll go to the top view and do two axis by a point. And so now, basically wherever I drop a point, and let's set our grid diameter here. Do like a 50,000 spacing. Alright, so we'll drop one right there. One over here. So you get the idea. We place one and we get four. Let's do one over here. And just to really show some more functionality, let's go to wireframe for a second, and we'll see that all the keyed pins are facing to the left. Having been a mold maker for a while, I know that some shops prefer the key always face the center. So we're going to pick on individual control and pick these guys on the left, and we're going to spin those in Z180. That'll get the flats facing the center. Okay, and then we go back to group control, and we do individual control once more. And let's see if we can make this one pin different. So I'm going to make this one a 1/4 inch. Okay, and just like that, I've made that one pin a 1/4 inch pin, while the rest of them are 3/16. Pretty wild. And so we're going to place that without cut. For whatever reason, that pin didn't come out long enough. I've actually not done this before, so I don't really quite know why. But we can fix that easily enough. So let's hide a couple things here. I'm going to double click on that pin, and let's pull the catalog length. Okay, so now it's an 8-inch long pin, and I can go back here in my previous display states. Okay, and now we're going to do ejector trim. So the ejector trim will cut off the tops of the pins. And we're going to trim by the movable side. We can do a shape trim, a flat trim, and we could do a flat trim to the highest point, the lowest point, or the midway point between the shape. But we're going to do a shape trim, and we're going to do an offset of 15 thousandths just to help guide the part out. I realize now that I picked kind of simple areas. I have placed one of these pins before in this area so that it straddled all these surfaces, and it's not a problem to trim over an area like that. It doesn't have to be a simple scenario where the pin breaks through. It really works well. There we can see all the pins are proud at 15 thousandths. So now we're going to do ejector pocket. we've selected all the ejector pins, and we're going to set the constant fit length. So if we look at the picture here, we're asking for the same length of land around each pin. Let's say that was 3/4 of an inch, and then we're going to clear below that. So the diametric clearance value is 1/32. The length of the land is going to be 750, and do it. Okay, so now we can see that we've got 3/4 of an inch of land around each pin. Obviously, that can be a pain for the guy programming them if he's not using some automated drilling like Cimatron offers. With our automated drilling, the software works off the solid model, and it knows what depth to drill each hole based on the model. Let's keep looking here. We want to turn off this one, and this one, and this one. And now we can see the keyed pin pockets. And again, remember, this pin was a bigger diameter than the rest. Now let's add some water. So we're going to activate the appropriate subassembly, being the movable side, and we'll choose cooling plane parallel, and we'll come up from this face. Let's see what 1 inch looks like. That looks good. And then we're going to sketch the cooling lines. And let's see, we'll add some reference to these edges. So we're going to sketch like this. And like this. And then dimension. Right, and then we're going to give ourselves a line to mirror across. We can change that line to a construction line easily. And then we're going to mirror these guys across this line. And then we're going to choose the cooling object. Okay, so there's a 7/16 water circuit, and we'd like to know how close are we to our ejector pins. So we can do a visual analysis. and we can check and see, are we within a 1/4 inch of hitting something. At a 1/4 inch offset, we're hitting that pin. So we know we don't have a 1/4 inch of meat there between the pin and the water line. So how about 1/8 of an inch? We're at least 1/8 of an inch away, but if that's too close for comfort, we can come back and change those values, obviously. So let's go ahead and take it for now, and we'll do it with cut. And then we can obviously edit the sketch, and we could make this 1.375. Okay, so now we want to add some fittings. So we'll do a cooling item. Now, I normally take the DME extension plugs. We may end up doing that, but let's just see what happens with the PCS ones. And a lot of times when we place components, we place it on a face. If I pick this face, I can only place 2 components. Cimatron has the ability to place on a cone face, which will let me go all the way around a block. Oops, that's a bad pick. Now, obviously we don't need these ones, those will just be plugs, so I wanted to demonstrate that. And I can see those aren't long enough, so let's take a longer one. Okay, that's not too bad. Let's see how this one works. We're going to place it with cut and see what we get. Okay, so let's turn on our B plate, and we can see that the B plate has got a cut, and it put clearance over here. Well, let's say we didn't like the clearance. Let's measure that diameter. So that diameter is 1 inch. That's not too bad. I know that some other catalogs will make that diameter 875, which is always too small. But let's say that our company standard was to make that 1 1/8 inch. Obviously we can do a face offset, but I want to show that during the add of these components, we have access to all of that information. So if I look at the edit parameters, we can look at the cut values, and we want to find that 1 inch diameter, which is right here, and let's make that 1.125. And let's back the length off a little bit. Let's go 5 1/4 on the length. Okay, so now this diameter should be bigger. We got the 1 1/8 that we asked for. But I'm not sure that length worked out like I expected. Let's edit that and look at it once more. You might need to look at this picture. We got an actual length. We got a L value. Alright, let's try changing this. Actual length. Let's see if 3.75 changes that. Well, I think I'm doing something wrong, but I know you can type this in and get a different length. Yeah, I apologize. I'm not able to get that changed, but trust me, it works. It's clearly operator error. Okay, so now let's add the plugs that go here. And we're going to place our cone face. Alright. And let's see, we'll do the runner next. So the runner tool is a lot like the gluing circuit. It wants us to pick a plane. Okay, so this isn't flat, obviously. That's alright. So I think we want to create a plane there first. So let's do wireframe, plane. So here it tells me the plane isn't 2D, but do I want to create a plane that lies approximately on this face? And I'll say yes. And now we can create the other plane by doing runner design, parallel plane. We'll pick that one that we just made, and we're going to do a 0 offset. And by creating that, it creates a part here called the runner part. And from here, we're going to do a pattern sketch and go to the top view. And we're going to create a line like this. And dimension it. And then we're gonna, well, actually, let's edit that. I want to change that. It would be better if I had some cross lines here to really kind of show it a little bit better. So I'm going to create a secondary runner like this, and we'll even come in maybe like that, like this, and then we'll dimension this one. Let's go 47.5. Yeah, clearly it's been a long time since I designed in real life. I forgot the cold slug, so we're going to edit that. Put a little cold slug on it, and we'll do a dimension here. Oops. Like this. Let's back this off a little bit. 2.25. So that one's already dimensioned. I think I want to do, let's go a half inch on these guys. Half inch there, half inch here. And then we just got this one to do. Okay. I think that's what I want. And we want to mirror all this stuff across. Alright, let's see what we get with this. Okay, so now we're going to do the runner bodies. And we're going to do circular. We'll do 312. Ah, I see something new. In version 13, we have an automatic cold slug well, so I didn't have to even draw those on. But we want to change this one to be a quarter. And then this one will be 188. Seeing though that took a little while, I'm going to be lazy and we'll just cut this and mirror it. So let's call that good for now. Okay, like I said, we're going to chop. Oh, wait a second. These are individual bodies still, so we can do this differently. Let's do remove geometry, and I'll pick these as solid bodies. And we'll do the old edit, copy, mirror. Mirror that across this plane. Okay, then we have a merge. And then we have a cut. So obviously we want to cut this one. Now we haven't actually created the insert for the cavity side yet, so we'll just have to pretend that that's done. And this cut would actually cut the core insert and the cavity insert at the same time. Here's something else. It looks like this is going to leave behind a runner body curve, which is going to be very useful for the NC guy. Okay, so now we're going to hide the runner part. And we see that we got the runner left. Yeah, looks like it got a little confused on the curves, probably because I did the cold slow wells manually, and it now has a feature to include those automatically. So probably that's the better way to go about it. So that's a lot of the tools for the mold design. You can get quite a far ways in a short amount of time. Adding a lifter is easy. There's a lot more things that we can show. I'll probably do another video to show maybe adding a lifter. Thanks for watching.